Now that we've learned how to do linear regression lines and exponential regression lines, we're going to learn how to find the best line of fit. How do we do that? So first we start by doing what we already know how to do. We're going to type in our data. Okay, so I'm going to go to Stat and Edit, and I'm going to put in list 1, 0, 1, 2, 3, 4, and 5. Okay, I'm going to go over to list 2, 20, 40, 75, 50. If you have a calculator, you should be doing this with me. Okay, one thing that's really important, and I talked about this in another video that I did, you need to check a couple things when you're done typing your data. Number one, these need to match. That means that there needs to be a number in both of those. You can't have an uneven number of data in each list. The next thing is you should actually go through and check and say 0, 20, 140. As you're checking your list and see, did you type it in? It doesn't take very long to look through your list and make sure that you typed your data in correct, and it will save you a lot of time in the long run. Okay, now that I've done that, what I'm going to do is I'm going to press my stat, my calc, and I've done this before. It first wants my linear equation, so that's where we're going to start, number 4. Okay, here we go for linear regression. And when I get that, I've got to reset my calculator just a minute because it wasn't there. This is good for you because I'm sure some of you forgot. If yours isn't there, what do? You go down to Stat Diagnostics and turn it on. Okay, so now I'm going to go back to Stat, Calc, and I'm choosing number 4 for linear regression. Okay, and there I go. So now I can write down my equation. So my linear equation is going to be y equals 94.17x minus 53, and I used a minus because it was negative, 0.43. So I did that to 2 decimal places. My linear correlation coefficient, remember that R is your correlation coefficient. So it is, and I'm going to go to 3 decimals this time. You don't have to, but you know what? I might as well write them down now because in a minute you'll see that we're going to be comparing our correlation coefficients. And the more numbers, the better. So 9, 2, 9, 3. Let's write down 4. Okay, you can round it when you if you needed to type it into an assignment or something, but for right now, we'll go ahead and do that. Okay, next up, we don't have to type the data in, it's already there. But this time I need my exponential one. So if you remember, the exponential should be down right here at 0. Okay, go ahead, you've already got the data, press that, and we're gonna write down our equation. So the equation is y equals, this one says A goes first, so 20.51, and then it's times B is 1.92 to the power of x. That is an exponent x. My exponential correlation coefficient, once again, is R, and it is 0.9994. Now, if I needed to round that, once again, for an assignment, this one would round to 0.93. This one would round to, actually, that one's going to round to 1. Okay, so the question is, it says, which equation better fits the data? So you're looking for which one has the strongest correlation coefficient. Now, both of these are positive, very strong. Okay, this is positive, very strong. This is positive, very strong. But we're trying to see which one is closest to 1. Hopefully you're saying, oh, well, it's the one that rounded to 1. Okay, so it is my exponential one. So you would say exponential. Okay, and then it says, use that line. Oops, I wanted to make that go down a little bit, but I don't think it's going to. Oh, maybe if I do this. Okay. Okay, now that it says down here, it says using only the better equation. What that means I can do is I'm going to ignore my linear one. This is the one that makes a difference. It says where would, or how many bacteria would there be in 8 hours? So hours. First I have to decide, is that X or is that Y? Well, hours is my X, this is my Y. So that means I'm going to plug 8 in for X. So I'm going to say Y equals 20.51 times 1.92 to the power of 8. So here I go back to my calculator. 20.51 times 1.92 of 8. And I'm going to press enter. And that is the number that I'm going to get. It is, let me see if I can make that go again. Okay, 3,787.7. If it asked me to round to a whole number, I would say 3,788. And there you go. That's how many bacteria there are. Okay, so on every problem, I'm not going to do another one. I think this is sufficient, but you find the linear first. You find the exponential second. Make sure you write them down. You're not going to remember what they are. After you do that, you're trying to find the correlation coefficient that is closest to 1. That is the one that you would use to answer the question. All right, hope that helped. Good luck.